Today's problem is kth largest element in an array. Given integer array in nums, an integer k return the kth largest element in an array. All right, let's look at the examples here. In the first example, we have a list of numbers, 2, 3, 1, 5, 6, 4, and we have k2, and the output is 5. And the reason why we get 5 because we are looking for the second largest number in this array, so which is 5 in this case. Okay, so in the second example, we have k 4, and that means we want to get the fourth largest number, and so on. So that's why we get 4 in return. Okay, well, so the obvious way to solve this problem would be sorting the array. Okay, to sort the array, we have a built-in function coming handy. It's sorted, and then we could just pass in numbers, and we give it a variable name res. Then we can just simply return res at index k. Actually, it's going to be negative k. The reason why we use negative here, because all those biggest numbers are going to always be at the end of the array. Okay, and let's run this to see if it works. All right, it's being accepted. Great. So the runtime of this is like n log n, but how can we do better? Actually, there's another way, an interesting solution I find in the discussion session that I would like to share with you guys, and it's called quick select. And all right, so let's talk about the idea of the concept. Is like we pick a random number to be the pivot, and then we create a couple of arrays responding to the pivot, and then we use conditional logic to figure out the recursive arguments. All right, and I know it sounds a little confusing, but I will give you a walkthrough later, line by line. But now, please just bear with me, and let's code it out first. First of all, we need to take care of the edge cases, which is if there's no number existed, we're gonna just simply return nothing. Okay, and then we create our pivot, and we use our random method dot choice to randomly select the number inside of nums. Of course, we need to import it. Import random. All right. Let's follow up, and we need to create our arrays. So we're gonna have 3 arrays: left, mid, no ID, mid, and right. Okay, and then we're gonna use our singular for loop, and x for x in nums if x less than pivot. Hopefully you are familiar with this syntax, and what it does is to see if any value is less than pivot, and it's gonna go to left array. Since they're all the same, and I'm gonna just copy and paste them here, and then change the conditions. For time's sake. Okay, so here is gonna be equal, and it's gonna be greater. Okay, so if it's equal to, the value is equal to value, not value, the pivot, and we're gonna store it into the mid array. And if it's greater than the pivot, and it's gonna just go to the right. Okay, and after that, we need to get the size of the middle array and the right array. Okay, and we're gonna use capital letters M and R, and length mid, and length R. All right, so what's next? And okay, let's move to our logic session. if k is less or equal to r, and we're gonna do a recursive call, find k largest, and we're gonna pass in our right array as the first argument and k as the second argument. In this case, k is gonna be, what is that? 2. Okay. And for the second condition, we have if k is greater than r plus m, and we're gonna call ourselves again, k is largest, but this time we're gonna pass in left as the first parameter, and k minus r minus m as the new k, and else we're gonna just return mid at the 0, at the index 0. Oh, let me indent it a little bit. Okay, so all right, so what does it do is to tell if the value, if k is less or equal to r, and we know our potential value is going to be in the right array, so that's why we just pass in the right array as a new array for the second run of the callback. And here, if k is greater than r plus m, and it's going to be in the left array, so that's why we pass in left, and then we're going to narrow it down k using k minus r minus m. Okay, let's run this to see it will, well, local variable r referenced before assignment. Oh, okay, here should be right, not r. Sorry for that. Let me run it again. It's not defined. My. Okay, I forgot to use self keyword. Yeah, I've been repeating this mistake again and again. All right, and let me run this again. Hopefully it will pass. Ready? R on line 15. Oh, it should be capital R. Okay, let me. Sorry if you're still here. Oh my god. Okay. Please bear with me. I'm kind of tired. A long day. Ready? Capital R. Okay. If you want to go, okay. All right. So finally, it's being accepted, and I know it's kind of confusing, and so here I have created a diagram for you to hopefully it will help you get a better understanding of the concept. Okay, so here we have a couple of stickers on the left side. Two smaller ones are those initial values, a list of numbers and k, and the bigger one is our conditionals, right? Which is this part. Okay. All right, and we also have a bunch of pivots, and we pretend they are created by our system. Okay, and this is our this is not our code, like this is a pseudocode. Okay, so let's dive into it. The first one, we have a pivot 3, and k equals to 2, and then we have 3 arrays, left, mid, and right. Since our pivot 3, our mid array is going to be 3, and the left one is going to contain 1 and 2. They're both less than 3, and for the right one we have 5, 6, 4. Okay, and then we get a size of the length of the mid one and the right one, and then we hit the condition to see if it'll fit like what's the best case for this? Since k is less or equal to r, because k equals 2, right? R is 3, so we're gonna hit the first if statement. So then we're gonna pass in our right array 5, 6, 4 as a new array for the next recursion. And then in the second round, we get a new pivot, which is 4, and k still stays the same, 2. And mid array is 4, and the right array is 5, 6. Why? Because remember we have our 5, 6, 4 as of a new array, like the base. So this time we get the length of the mid one is 1, and the right one is 2. It still satisfies the first condition, right? So R2 is equal to K. So we're gonna, hit the first one again. But this time we're gonna have our 5, 6 as a new array in the second round. Okay, so this time we get a new randomly selected number 6 and K2, and left array becomes 5, and the right array is empty this time, which means we're gonna only have the size of the middle one, which is 1, and it's gonna hit the second condition because k is greater than r plus n, which is 0 plus 1. And then we pass in our left array as the first argument, and the k is gonna be a new k, and it's gonna be 1 because 2 minus 0 minus 1. Okay, k minus r minus m. And then in the last round, our pivot is gonna be 5 because that's our only option in the array as the left array pass in, and the k is gonna be 1. Remember, this is a new array. This is a new k. We got it from the operation here, and then we hit the third one, the last case, which is just simply return whatever we have in the mid array. Okay, so hopefully this kind of content can help you clear up any confusion. And for the time complexity, it's gonna be all of n. Okay, I think that's it. And if you have any questions about why this solution works, please do not hesitate to ask them in the comments. And I will see you next time. Bye.